Good morning. We were discussing about the contamination or a pollution issue which is a very critical aspect for the design of line insulation in case of overhead transmission insulators. So, there again we have discussed about the AC transmission and the DC transmission. We will focus on some important guidelines which have been framed by the standards and also the working groups in this particular insulation area. So, for the pollution testing we have also looked into the laboratory aspects, how the insulators are being tested for the evaluation. Similarly, for the DC, as I mentioned earlier, several long distance transmission HVDC lines are coming up in the country, up to 800 kV lines. Several lines have already been in functioning, and one of the line also which mentioned is the longest line in the world, which is from Arunachal to the Agra. So, very important aspect for EHV and UHV, we have discussed about the contamination or a pollution issue. So, there are few guidelines. I would like to share some information which are in the standards. We have IEC standard 60815. This is a very important guidelines which gives the information of the selection of insulators, particularly in respect of polluted conditions. This gives the idea where exactly the insulators, how the creepage length has to be chosen, how the insulator dimensions have to be chosen depending upon the area of the insulators which are being used. So, there is again a task force by Seagray 3304 which has also come up with an important document on polluted insulator, where it gives the information of how to use the insulators, could be of ceramic, glass or porcelain in various conditions. As per the testing aspects is concerned, we have discussed the exact simulation of the contamination or pollution problem in the laboratory is a difficult task. So, we also looked into the theoretical aspect or a modeling aspect which could be done is also equally difficult as involves several parameters which have to be considered, and the dynamic nature of the changes which happen in the parametric, like wind, direction of the wind, the rain, the velocity. Several of these things do not give us the exact idea of to simulate or come up with the exact modeling. So, even the laboratory testing, the experiments are being framed using the standards as IEC 60507. This is a technical document which gives the methods of artificial pollution experimentation or tests to be carried out on the various insulators which are to be used in the AC transmission systems. So, there are again the methods which are specified, how the insulator is to be contaminated, the spray, and how the experiments have to be conducted. So, for all the AC transmission system, the standards are defined. Similarly, for the DC, IEC specifies 1245 is the standard which gives a guidelines of the simulate the conditions in the laboratory and how the artificial pollution tests to be carried out, particularly for the DC insulators. We have already discussed there is a difference between the AC and the DC insulators. So, DC insulators require different arrangements or the experimentation wherein the creepage is very high, the material which is used for the DC is slightly different in case of the AC insulators that we have discussed. The alumina content even in the material should be higher, and these insulators are also to be done. So, that methods which are adopted are similar in nature to the AC pollution tests, but with modifications. So, these are clearly mentioned in the standard 1245. So, here in the laboratory we have conducted or developed the experimental setup for conducting the pollution flashover or a pollution withstand or a pollution performance experimentation on various types of newly developed insulator by the manufacturers in the country. So, these insulators are being used for various high voltage HVDC transmission lines in the country. So, several new type of insulator discs which are developed by the manufacturers, well known manufacturers in the country, are being experimented. Here the facility which we have developed exclusively for the pollution performance for HVDC has a capacity of 250 kilovolts with 100 milliamps source. So, the AC setup which was existing has been modified, and the same chamber which is a 5 meters cube, 5 meters by 5 meters is being used. So, a typical experimental arrangement is shown here, wherein you can see the specially manufactured DC insulators are being used. This is the high voltage, and this is being the grounded. So, we have used various nozzles as per the IEEE standards to simulate the fog conditions or the rain conditions. So, various insulators of various creepage lengths particularly used for HVDC are being used. In the laboratory, the facility is also been made using an IR cameras to particularly find out the location of the discharge activity during the experimentation for a pollution when the experiments are conducted for long duration of time. So, here as mentioned, the facility has been designed up to 250 kilovolts DC. The nozzles designed for fog generation inside the pollution chamber as per the standards, as per the IEC and IEEE standards. One of the example is shown here, where the water from the nozzle one side of the nozzle, another the air is pumped. So, the fog which is generated is applied to the insulation in the chamber. So, the moisture free, as mentioned, I told you, this is the IR cameras which are used for recording the activity inside the chamber. So, various experimentation on single discs, 3 discs in a string, because the facility can cater up to 250 kV. So, the experiments have been conducted on the insulators, single 3 strings and 6 insulators in a string. So, this is the facility how we have adopted the same transformer which was used for 150 kV AC pollution test, which is a 150 kV 2 amps, 100 kV 3 amps and 50 kV 6 amp source is been suitably converted to a DC with using the rectifier and coupling capacitors, smoothing capacitor, so and a measuring unit. So, where this output of the DC is 250 kV with a very ripple content being very less and as per the standards. So, some of the experimental information or experimentation insulators of various types as mentioned from different manufacturers with different creepage distances and dimensions have been employed. So, several insulators have been tested. A typical or a few values which are being shown here, example like a creepage distance for a particular type A1 is somewhere around 395 and the disc diameter is 280, the height of the disc being 170, the mechanical strength of the disc being 210 kilonewton. This is used for plus minus 500 kV voltage levels. So, these insulators are picked and the single 3 insulators in a disc and 6 insulator in disc are being experimented in the lab. Similarly, the other type of different manufacturer where you can see the creepage length is 590 and the disc diameter is 300, very big disc with a height of 207, a mechanical strength of 420 kilonewtons, and these insulator discs are used for plus minus 800 kV systems, HVDC systems in the country. So, various experimentation as per the standards using cold fog, steam or the spray methods have been followed, and the activity particularly the insulators are coated as per the standards and the experiments are conducted. The intention is to see how the inception of the scintillations or a partial arcs which originate from the pin junction are known and how to arrest this. This was one of the study which was conducted wherein precaution or wherein the method was developed to reduce the scintillations or the partial arcs for the insulators which are used for high voltage DC systems. So, these are some of the values which have been obtained, say in case of a 395 creepage distance. The inception of the scintilla, inception of the arcs, what we call these discharges, whatever you see here, the inception, the starting point of these discharges were anywhere between 14 to 15 kilovolts, and the flashover was 41 or 40, nearly around 42 kilovolts in case of these discs which are done using the cold fog method. So, cold fog and method is very clearly explained in the standards 1245. Similarly, for the B type insulator, the inception of scintillations was noticed at 10 kilovolts itself, and the flashover was 38. You can very clearly see that even though the creepage distance is very high, the inception of scintillation takes early. So, the design aspect is very important. The inception of scintillation is to be limited or arrested, so that further the discharge activity will do not come across. So, similarly, using a steam fog, I told you the cold fog method, and using the steam fog method, the experiments were conducted for both single, 3 and 6 disc insulator. So, these results show conducted for the single disc using a steam fog method. So, for the type A1 we have a scintillation or inception of discharges happening at 72 kV, typically around similar voltage levels what we have seen. So, in case of cold fog the inception was 2 to 3 kV earlier, here it is later because of the steam fog, where it takes us a time for the surface to conduct and the scintillations to happen. Similarly, for the B type, the values are 13 kilovolts and 40 kV, 39.6 kV is the flashover voltage which have been noticed, and various number of discs different, at least for each type 3 discs of same dimensions were used for the experiments. Similarly, using the steam fog, as mentioned, 3 discs in a string were also carried out. So, you can see the scintillation inception is early in comparison to the single disc, and the flashover voltage being 71 kV. So, the single disc you can see it is 43 kV. When you put 3 discs, it is not a linear phenomena where you can see the increase of the flashover voltage. So, these values, similarly for the insulator B2, you can see the scintillation starts around 21 kilovolts in case of 3 discs in a string with a larger creepage and diameter which I mentioned earlier, and the flashover is around 74.9 kV for 3 discs in a string. So, it is to be noted here, in case of a single disc for type A1 the flashover voltage was somewhere near 44 kilovolts, but in case of 3 discs it should have been, if it is a 3 it should have been 120. So, it is not that the phenomena, the surface discharge, the scintillations which are happening further depending upon the stress, the entire creepage bridges at 72 kV. You can see that the phenomena of pollution or a contamination is a very dynamic phenomena which happens during that period of time, how the scintillation spread, how the activity happens, how the formation of dry bands, the formation of surface conduction and the surface resistance. Several of these things play a role, including in the field it happens, the wind, the direction of the wind, the contaminants spread on the surface, all these parameters do affect the scintillation activity, and the flashover could happen. Again I am stressing at normal or working voltages. So, these are some of the results very important, thought of sharing these results and comparing the values. Always a point to be noted that in case the insulator number goes on, the flashover goes up, it is not a linear phenomena. That is the reason just I have tried to show the values which have been experimented for various disc insulators. That was about the DC for method for the contamination or the pollution which are being followed in the laboratory, any laboratory, standard laboratories before the insulators are being used. So, we have discussed about the pollution on AC, the DC aspect. Earlier I have mentioned about the importance or the pre-maintenance or the maintenance before the monsoon, where this pollution activity causes the flashover. So, there are standards for this. One of the standard is the IEEE standard 957, which describes or which guides the frames the guidelines are given for cleaning of insulators for ceramic, glass as well as the polymer insulators. So, this provides very useful information to the utilities and the people who are supplying the power to the consumers to take suitable necessary action, particularly in the winter conditions or the ice fog conditions, and see that the cleaning of insulator is done, and the flashover or the flashover or the blackouts which happen during the contamination or the rainy conditions or due to the fog can be reduced. So, with the intention of this, the IEEE guide for cleaning insulators has been framed, very important information to the utilities as mentioned. So, we would like to highlight a few things about the contents of this standard or the guide which has been framed. So, most of the time in the transmission system or in the distribution system, you cannot or the utilities cannot switch off the power and try to clean the insulators. So, it has to be done by the live line washing methods. So, proper insulating bench and nozzle sets are to be used with a suitable solution or the water content with a particular resistivity which is given in the standard has to be used during the conditions where without disturbing the normal conditions. That is what is known as a live line washing or hotline maintenance of the insulator strings or the substation equipment. So, methods, some of the methods which are highlighted in the standards I would like to mention here few. So, methods of cleaning of transmission insulators, particularly in service, this is known as hotline or live line washing techniques. So, the utilities or the power grid normally use various types of nozzle sets, either of which are normally of high pressure. So, these high pressure water nozzle sets should have a capacity of 2750 to somewhere around 7500 kilopascals with 400 psi to 1000 psi at the nozzle. Sometimes these numbers could be slightly reduced in case of the traction insulators which are operating at 25 kilovolts. Again, these traction insulators could be of ceramic or polymer type. So, there some of the literature mentions about 250 psi to 350 psi where it is used, and here 1000 kilopascals to 1250 kilopascals, so on. So, these are for the transmission insulators. So, 4 types of nozzles are normally employed which are of high pressure. Either it could be handheld jets or a remote control jets or a fixed spray or the nozzles mounted on the helicopter or a helicopter mounted nozzles. These are the 4 different types of nozzle sets which are being used by various utilities for the cleaning of the transmission insulators. So, how the handheld jet it is normally a line worker or the maintenance personnel or the maintenance technician climbs the tower or uses an aerial lift to raise the hose and nozzle to the position of the insulator string to be cleaned. So, this is how with the help of a hand jet the technician tries to use the nozzle jet. Similarly, remote control jet, again here the nozzles are mounted on a truck boom which are similarly shown here. Similar to this, you can see the string of insulators which are being cleaned using the truck mounted nozzle sets. Here the system permits positioning of the wash streams. So, suitably the truck is adjusted to clean the insulators, either it could be a tension or the suspension type, but this has a bit of difficulty for using in case of V type of string where suitable arrangements have to be done. So, there are again fixed spray nozzles which are also being employed by the utilities. These have an effective in preventing the particularly sea salt. So, the transmission lines which run near the sea coast where lot of salt contaminants get accumulated over a period. And so, they normally use these fixed spray nozzles to clean these contaminants to prevent the flashover phenomena of problems. So, the utilities watched and the parameters and the equipment should be suitably developed and used. It is not that commonly the parameters are kept same similar to the other conditions of the environment. So, the parameters could be like the precipitation, water resistivity. So, how much is the conductivity or resistivity of the water, and the wind, the contaminant severity of that location, design and installation arrangements of the insulators to be washed. So, several of these parameters come in the way of designing the fixed spray system for cleaning the insulator. Sometimes the insulators, if the system or the parameters are not properly tuned, there could be wear damage to the insulator petticoats or insulator shells. So, very important aspect to tune the parameters to the required location of the insulators and with required pressure, and the nozzle arrangements have to be done. This gives some information about the minimum distances from the energized washing. So, this is again available in the standards which I mentioned for cleaning of insulators. So, to show you how a typical example, in case considering some voltage levels here, say 33 or 35 kV, 34.5 is the line voltage. In such cases the minimum nozzle to conductor distance, so it mentions is 2.4 meters. So, a person or whatever the arrangements, the nozzle sets have to be at a distance of 2.4 meters, and the conductivity or the minimum resistivity of water is mentioned to be 1300 ohm centimeter, and the pressure, minimum pressure is 2758 kilopascals, and the maximum orifice of the diameter is mentioned as 6.35 millimeters. So, this is a typical example which I have cited. Similarly, for 66 kV, 230 kV and above 400, 800 kV, the values could be slightly different, and the distances also could change. So, very minimum distances for energized washing, because the proper precaution has to be taken as it is a live line washing. So, suitable care has to be employed. These have to be strictly and followed about the conductivity, the minimum pressure, and all this are given in the standards. The helicopter mounted, which I mentioned earlier, again here the helicopter mounted nozzles system is normally being used in case where the other type of arrangements like the truck mounted nozzles or the handheld physically where a personnel could use or utilities maintenance personnel could reach is difficulty. In such cases where the transmission lines or towers are situated on the hilltops or in high altitude conditions, or it is very difficult to reach the towers, in such cases helicopter mounted nozzles are generally used for cleaning the insulator system. Here the system is normally controlled by the wash operator or the pilot. Generally the helicopter hovers near the insulator string and operates operation of the position near the nozzle to direct the stream of the jet to the insulator. So, this is carefully adjusted. You require a lot of skills to see that when you are near the high voltage transmission lines and operating the pilot and also the trained personnel who are using this water jet have to be properly trained to use the system. So, fixed nozzles, again here sometimes the pilot controls the direction of the water stream by a movement of the helicopter depending upon his arrangement. The distance as mentioned, again in a suitable distance, minimum distance has to be kept away from the transmission lines depending upon the voltage levels. So, movable nozzles on the fixed one, the helicopter is generally moved to the general location and the nozzle controls the direction of the stream. So, several of these options are given to see the proper cleaning of the insulators are being done for the towers which are situated on the high altitude or the places on the mountainous areas where a normal reaching to the spot is difficulty in case of the truck mounted nozzles. So, fixed nozzles in a mobile van, the helicopter gets to required general position, and then washing is actually controlled by the other person who is also assisting the pilot. So, several options are being done to see the proper cleaning of the insulators in the transmission system is carried out. That was about the cleaning of insulators. Now, we have discussed about the pollution, contamination issue, how the phenomena occurs, how the remedial measures have been adopted, several remedial measures apart from the developed measures which we have also contributed to the improvmental aspect in the contamination or pollution issues both for AC and DC conditions, cleaning methods, preventive maintenance aspects, live line washing and so on. So, what happens in case of the faulty insulators I also mentioned that in case of the insulator string, particularly in transmission system, for a 220 kV system you have anywhere between 14 to 15 insulators or 13 to 15 insulators in a string. For 400 kV it is 23 to 25 disc insulators. For 765 it could be 35 to 40 insulators, or depending upon the creepage, a larger creepage could be of 29 to 30 insulators for 765 kV AC systems. So, in these strings what happens in case there are few discs which are faulty in nature. So, again how the modification of the field changes, how the potential of the string gets modified because of the faulty insulators. This is a very important phenomena to be noted or to be considered by the utility engineers. This will help in the proper maintenance. So, in case there are few discs which are faulty in the string, so there is no necessity if the effect of the redistribution of the potential field takes place wherein the flashover could not may not happen. In such cases immediate removal of this faulty may not be required. So, a lot of effort has been put into this study, wherein both experimentally as well as theoretically it is studied that the faulty insulators sometimes play a major role, and see that they have to be immediately replaced, and in some cases it could be done at the later. So, we will see into these aspects. These faulty insulators could be due to several reasons. It could be because of the vandalism, it could be because of the over voltages which could have happened in the shattered the sheds, or it could be because of the cement, the Portland cement near the pin junction wherein the cement growth happens over a period of time and the cracking of the insulator happens, and it gives the insulator becomes faulty. So, what happens in case in the field, you can see here a string of glass insulator, a particular location it has been shattered, this insulator has been shattered here. So, whether such things in case it happens very near, this is the line end of the string, this is the tower end, that is the ground end, this is the line end where 4 conductors are there. So, what happens when these insulators are shattered, damaged very near to the line end, how the potential changes or how the field gets modified, and whether this could lead to the flashover. It is a very important phenomena. Many people have tried to understand this so that which will be very helpful for the utilities. So, there are apart from physical or visual examinations, there are methods to find out the defective insulators. In case of glass insulators, as I mentioned, none are required. As you can see, if there is a shattered insulator bell, it could be visible from the ground end, and a suitable action could be taken whether to replace it immediately or depending upon the fault or depending upon the bell which is disturbed in the string. See, for a ceramic or a porcelain, several methods or commercial methods are available which are normally being employed by the utilities and the power grid engineers. So, these are reasonably expensive, and also the standards exist for live line maintenance for measurement of field and to find out whether these are insulators are faulty or good. So, say for a composite insulators it requires lot of expertise, as mentioned these are of recent origin. There are methods still yet to be developed for the maintenance, live line washing, cleaning of composite insulators, and also the methods for detecting faulty insulator strings. So, presently these are some of the methods. Like electrical methods, the techniques which are employed are the field measurements. It could be using sensors. The voltage distribution method, it is normally conducted in the laboratories where the voltage is measured across each disc in a string, and the percentage voltage distribution is found out, and it could be found that insulator string which has fault could be rectified, and it could be seen that this particular has to be changed. Similarly, there are methods which they use insulation resistance method for finding out the faulty insulators in the string. There are methods used like ultrasonic detection or a corona detection gun. These again come under the classification of acoustic methods, where a pulse or a ultrasonic methods are being done. Visually, as mentioned, it could be from the normal eyesight where you can trace and find out whether the discs are whether in the field, like previous which we have seen for the case of a glass insulator, the fault of the insulator could be seen through a normal eye. There are methods which are used, ultraviolet enhancement and infrared cameras or UV cameras, which also give the information about the insulators being detected for the faulty conditions. So, ultraviolet enhancement, infrared cameras, eyesight for in case of visual, acoustic methods and electrical methods are generally used for detection of insulators. So, what happens in the field? So, we have also tried to understand the phenomena, how it happens, how the field gets modified in case of faulty disc in a string. So, the modification of potential and electric field particularly in case of ceramic disc insulators with faulty units in a string are studied for various voltage levels, both experimental and theoretical, and gives an important information to the utilities, particularly in case whether the change is necessary immediately or how is the importance and where exactly the faulty disc insulators in case available in the string to be replaced. So, several experimentation and theoretical simulations have been conducted by the developed method at the laboratory. We have tried to see the using the surface charge simulation method. This is one particular experimentation simulation which has been carried for 3 disc in a string. So, 3 disc 33 kV is the potential at the line end, the second will be at the potential somewhere around 20 to 23 kV, and third will be around 11 or 13 kV. This blue one is for the normal healthy string. What we call healthy is that without the discs in the string are faulty. What happens in case there is a faulty disc in the second? So, you can see the red curve here, 33 kilovolts is the first pin or line end. Once the second disc is faulty, the potential comes down and you can see the rise in potential at the third disc. So, this rise in potential will cause a potential difference or a field effect on that, which will be a very serious threat in case of the strings which are of containing number of disc in insulators for 400 kV, 765 kV, which we will be observing. See, this shows for 120 kilonewton discs for a 400 kV system, where the potential gets modified in case you can comparison has been done for the healthy and the strings which are faulty, particularly considered in the second and third disc near the line end. What happens? So, you can see the green curve, this is the green curve which shows for the healthy conditions, the green curve here. So, the potential gets immediately modified for the fault conditions. If the fault is at second, third or second, third, fourth, you can see this last is second, third, fourth fault conditions, and this is for the fault conditions of the second and third. So, in case what happens, entirely the potential gets modified and you can see the rise in potential near the first disc happens. So, once this rise in potential happens, you can see somewhere here to here the stress at the line end increases and there could be discharges across the first disc insulator. Initially the cascading effect could cause a serious blow to the string. So, immediate replacement is required. Similarly, what happens in case there are failures in the middle of the string? You can notice that in case of middle of the string, the field gets modified, but not much of disturbances to the initial conditions. So, no major threat happens. So, even the fault conditions are somewhere here in the last 20-25 near the ground end, not much of serious effects. So, similar study was conducted for various insulators, 160 kilonewtons for 765 kV line, that is 35 insulators in a series. Various fault conditions were simulated for 400 newtons. This is again for 29 disc in a string 765 kV line. So, again you can see how the field gets modified depending upon the insulator location where the faults are. They can see the second and third fault, how the field gets modified here. Potential gets modified. So, you can see the green and the other faulty conditions. This creates a very gives a important information. These are some again the experimental and simulated results in the laboratory for a 9 disc insulator string, where we have tried to see the failures which intentionally faults have been created and the study has been done. So, overall when you look into that results of a 400 kV transmission system, when you take the defective insulator in case if it happens to be in the second and third or a fourth from the line end, that is a high voltage end. So, the electric stress across the first disc, which is a good insulator very near to the conductor end. So, you can see the rise in potential or electric stress, rise in electric stress is 100%. So, double the stress which it was facing when all the insulators were in service. Similarly, in case of the second is faulty from the line end, the enhancement will be 33% across the first disc. For second and third, the enhancement will be 60. So, as the number of discs from the line end leaving the first insulator, if other insulator second, third, fourth are faulty, the stress across the first disc will be rising to a very high. This could lead to early scintillations, early flashover across the first disc. Cascading effect could cause the seriousness of the entire string flashing over. So, the enhancement in electric stress across the normal insulators is minimal when defective insulators are located as mentioned earlier at the middle, that is if in case of a 23 discs in a string. So, after 13, 14, 15 and at the ground end, not much of impact or not much of electric stress which is seen. So, this is one of the important point to be noted. So, several experimentation and also the simulations have been carried out for various strings considering the faults at various locations in a string. So, it happens in case of a 66 kV line, the first disc is somewhere around 50 to 58%. For 132 kV system, the stress could be increased depending upon the second or third disc in a string. If the faults are available, the stress could increase up to 60. For 220 where disc could be of 13 to 15 discs, here there are faults on second and third, the rise in electric stress could be 66%, which is faced by the first insulators. Similar stress for 400 and anywhere 40 to 78% in case of 765 kV. So, you can see that the normal conditions, the second or third disc are faulty, the stress increases. This increase in stress again because of the contamination or because of the fog, this could see the effect much more, and finally the insulator string could be the failure of insulator string could happen. So, what happens in the case of the faults where 3 insulators are shorted or faulty in the string from the line end. So, you can see the increase will be more than 100% for 400 kV and 765 kV disc insulators. So, this table gives the entire information about the percentage of electric stress across the first disc. Here the first disc assumed is the good one, the second, third and fourth are treated as faulty, and the simulations have been conducted and the stress calculations have been made for various discs. You can see from 160 Newton to 120 Newton, 400 Newtons. So, these discs are normally used for HVAC DC lines, and where in case of second disc is faulty, the voltage levels are also given here. For the faulty of only second disc is faulty, these are the stress values which increase across the first disc. This second and third disc considering faulty for various voltage levels up to 765. You can see how the percentage stress increases across the first disc for various voltage. For a typical 765 kV, you can see 73% increase in the stress across the first disc is noticed. So, similarly for this is 29 discs for a 400 kilonewton insulator, where 58% of the stress is increased across the first disc. So, for 3 insulators faulted conditions, that is the second, third and fourth from the line end, these are the stress values how the insulator sees, the first disc insulator sees. So, very important study which has been done. This gives a very important information in case the insulators units are faulted after the mid of the insulator string, not much of a worry, whereas if the discs are faulted in the near the line end, the first after the first insulator, second, third, fourth serious is to be considered, it is very serious, and the utilities have to immediately take necessary action in changing the insulator and improving the bringing down the stress level across the first disc insulators. So, here we have completed about the ceramic disc insulators, the pollution phenomena, about the methods which are employed for the laboratory conditions, the cleaning of the insulator in the pre-monsoon and preventive maintenance, then about the insulator discs which are faulty in the system, it could be of glass or porcelain, how proper care has to be taken by the utilities, and how serious is the issue in case the fault discs are located at second, third or fourth, or in the middle or at the end of the insulator string. So, we will stop here. Thank you. Continue.